So today we'll discuss about the topic which I had taken the class yesterday, that is dielectric. Okay, so what is dielectric? Dielectric is an insulator which can be polarized. Dielectric is an insulator which can be polarized. Now I've told many things here. Okay, now step by step I'll make you understand. So what is an insulator? Insulator is a material which does not conduct electricity. Okay, now what is a dielectric? As I had told here, dielectric is an insulator. So okay, it is an insulator, that is, it does not conduct electricity. But what is its special property? That is, which can be polarized. That is, in dielectric you can create dipoles. In dielectric you can create dipoles. Dipoles means basically it is separation of charges, just small separation of charges, very small separation of charges. Okay, so in dielectric you basically produce separation between charges. Okay. Now I'll describe it more in more details. So only the charges are separated by little distance. Okay, now okay, let me describe this in details. Let me describe it. So suppose you have an atom here. In atom, what do you have? You have a positively charged nucleus, and here you have got extranuclear electrons. You have positive charged nucleus, here you have got extranuclear electrons. Okay, so when E is equal to 0, that is no external electric field is applied. When E is equal to 0, that is no external electric field is applied, what happens? The total positive charge and total negative charge, they completely positive and negative charges balance each other. Okay, so net dipole moment is 0. Now let us see the case when an electric field E is applied in this direction. When an electric field E is applied in this direction, so what will happen? Because of the electric field, the positive charge will move towards the electric field and negative charge will move away from the electric field. Okay, as a result of which, what will happen? This this oval kind of or ellipse kind of shape will be created. Now here actually this dipole moment will be created here. Here the dipole moment will be created. Now here dipole is created. Okay, this one I should have told a little bit differently. Here also positive charge and negative charge balances each other, but here what happens? The center of positive charge and the center of negative charge are at the same place. Okay, the center of positive and negative charges coincide with each other. The center of positive and negative charges coincide with each other. Hence, this net dipole moment is 0. Okay. But here what happens? The center of positive and negative charges do not coincide with each other. That is why dipole is created, and hence dipole, hence there is a dipole moment. Hence there is a dipole moment. Okay. So that is the thing actually. So the example of dielectric are examples are what? Examples are glass, rubber, mica, porcelain. These are examples of dielectric. Now, what is as I said, the dielectric is an insulator, but there is a difference between dielectric and insulator. What is the difference? The difference is that insulator charges cannot be separated, but in dielectric charges can be separated. In dielectric, charges can be separated. So this proves what? This proves that all dielectrics are insulator, but all insulator are not dielectric. Okay, this proves this thing. All dielectrics are insulator, but all insulator are not dielectric. Okay, so this is the thing. Now and this process of creating or inducing dipoles in a dielectric material is dielectric material by an external electric field. By an external electric field is called as polarization. Is called as polarization. Okay. This is called as polarization. Now this dielectric are of this what is the use of dielectric basically? So in insulator they are mainly used for stopping of the electric current. Okay. The insulators are used to prevent the flow of electricity. Okay, so they are called as passive dielectric. They are called as passive dielectric. And dielectrics are used for what? Dielectrics are used for storing of charges. Storing of charges. Okay, they are called as active dielectric. So example of dielectric will be what? A capacitor. Okay, capacitor stores charge. Okay, now now comes the second part, that is polar dielectric. Polar dielectric. What are polar dielectric? Polar dielectric are those which have a net dipole moment. Net dipole moment. Okay, polar dielectric are those which have got net dipole moment at zero applied field. Net dipole moment at zero applied field. Okay, there is no resultant dipole moment. So example is what? Example is, there are many examples like H2O, CO2, okay, then H2O2. These are all examples. Now okay, now sorry, I told here something wrong, that polar dielectric are those which have got net dipole moment in the absence of an electric field, at zero applied field. Okay, so examples are H2O is an example, carbon dioxide will not be an example, H2O2 will also not be an example. Examples are NaCl, NaCl is an example, then HCl is an example. Okay, why? Because hydrogen, what is the structure of hydrogen? H double bonded O here and H double bonded O. Okay, so there will be a resultant dipole moment here. Sorry, not this. Very sorry. H2O. They are of H and O. They are of different electronegativity. Okay. Then NaCl. Na is of different electronegativity. Chlorine is of different electronegativity. So there will be a resultant dipole moment. And HCl, again there will be a resultant dipole moment because H and Cl are of different electronegativity. Then non-polar dielectric. Non-polar dielectric. What are non-polar dielectric? Which have got zero dipole moment. Zero dipole moment at zero applied field. Zero dipole moment at zero applied field. So here the example will be this H2, O2, N2, CO2. Why CO2 will be an example here? Because CO2 structure is C double bond O, C double bond O. So this and this will cancel each other. Okay, H2O2 will also be an example. H2O2. This will be an example of non-polar dielectric. Okay, now what is actually this dipole moment? You definitely have studied in HS about dipole moment. What is dipole moment? Dipole moment is, what is a dipole? It is a positive charge and a negative charge separated by a small distance. Okay, it's a D. Now what is dipole moment? Dipole moment is Q into D. This is the dipole moment, that is charge into distance is the dipole moment. Okay, now polarization is what? Polarization is given as dipole moment per unit volume. Okay, dipole moment per unit volume. Now dipole moment is what? Q into D. Volume will be what? Say D cube. So this will be Q by D square. So this will be what? This is actually surface charge density. Surface charge density. This is denoted as sigma. Okay, surface charge density. This is denoted as sigma. Okay, and what will be the unit of polarization then? Unit of polarization will be coulomb per meter square. Okay, it will be coulomb per meter square will be the unit of polarization. Okay, now comes your what is dielectric constant? Dielectric constant. Okay, now what is dielectric constant? Suppose you have got a capacitor here. It is charged by a battery of say on voltage say V. So what will happen? There will be positive charge here. There will be positive charge. This plate will be charged. There will be negative charge here like this. This plate will charge with negative charge. Okay, and there will the distance between the plates is say D. And area of this cross section is say A. Okay. So capacitance of the capacitor when there and in this space the space between the two plates is filled with say air. So C will be what? Epsilon naught into A by D. Okay, where epsilon naught is the permittivity of free space. Permittivity of free space. Okay. And A is the area of cross section. Okay, now suppose a dielectric is placed here. Dielectric is placed here. Okay, then what will happen? Suppose here this is the capacitance at when there is free space. So that is denoted as C0. Okay, then C will be what? C will be, suppose it's the permittivity of the dielectric medium is say epsilon into A by D. Okay, where epsilon is the permittivity of the dielectric. Permittivity of the dielectric. So C by C naught will be what? C by C naught will be epsilon by epsilon naught. Okay, so this is denoted as epsilon naught, that is relative permittivity, or this is denoted as dielectric constant or K. Okay, this is called as dielectric constant and this is called as relative permittivity. This is called as relative permittivity. Okay, so this K is a dimensionless quantity. Dimensionless. K is a dimensionless quantity K is called a dimensionless quantity. Okay, and it for air K is equal to 1, and for all others K is always greater than 1. Okay, this is the thing. And more is the value of K, that is the more is the value of K means more is the dielectric constant, more will be the capacity of storing charge. More will be the capacity of storing charge. Okay, now Another thing is that if capital N is the number of is the number of atoms per unit volume, then polarization is given as N into mu, where mu is the dipole moment. Mu is called as the dipole moment. Okay, now say the same thing, same drawing I am drawing. This is charged with a battery of charge, say V. So what will happen here? Positive charge will be charged here. Positive charge will charge in this plate. Here there will be negative charge. Okay, and here right now there is air here. So a field will be acting between the positive and negative charge. Let this field be E. Okay, let this field be E0. Let this field be E0. Now a dielectric is introduced. Dielectric is, say, introduced here. So what will happen? On this end of the dielectric there will be negative charge induced. Here there will be positive charge induced, like this. Okay, so similarly here there will be plus, here there will be minus, here there will be plus, here there will be minus, like this. So basically a dipole is created when it is placed inside between the plates of the capacitor. There is electric field, so dipole is created here. Plus minus, like this. Throughout the dielectric there will be charges created. Now within the dielectric there will be an internal field. What will be that? That will act between this plate to this plate. Let this be EP, that is polarization, electric field. Okay, so the resultant field will be what? Resultant field will be E is equal to E0 minus EP. Resultant field will be E0 minus EP. Okay, now suppose the surface density of charge here is, say, sigma, plus sigma, and here is, say, minus sigma. Here is plus sigma and here is minus sigma. So what will you write? And the surface density of the polarization charge is, say, sigma p. Okay, sigma is the surface density of the free charge in the plates, and sigma p is the surface density of the polarization charge within the dielectric. Okay, so this will be what? E0 will be what? From your class 11 you have studied this, that it will be sigma by epsilon naught minus, this will be similarly sigma p by epsilon naught. You have studied this in, if you recall back your class 11 physics book, you will definitely remember this. So from here what will you get? Sigma will be epsilon naught E plus sigma p. Okay, now sigma p is what? Sigma p I had written earlier. Sigma p will be actually p. I had shown it in the earlier lecture here, that is this one here. Did I show? Here this polarization is equal to, that is sigma. Sigma is equal to polarization. Polarization, this will be actually P. Okay, so sigma is equal to, sigma P will be equal to P here. So now this will be equal to P. Now from the Gauss's law we can write that sigma is equal to D, where D is called as the electric displacement vector. Electric displacement vector. What is this? What is this? How from the Gauss's law? What is the Gauss's law? You have studied it in class 11, 12, I am sure. Plus I had done it in the Maxwell's laws just before the holy vacation. That is, what is the Gauss's law? E dot ds, closed loop integral E dot ds is equal to 1 by epsilon naught into charge enclosed. Charge enclosed, you can write it like this, sigma into ds. Okay, so from here what you can write, closed loop integral of epsilon naught into E dot ds is equal to integration of sigma into ds. Now epsilon naught into E is nothing but the electric displacement vector, or the this is actually the electric displacement vector or the electric flux density. Electric flux density. Okay, so you can write, so from here we can write that D is equal to, you will write it vector, D vector is equal to epsilon naught E plus P. This is a very important conclusion, and this is called as the Gauss's law of dielectric. This is called as the Gauss's law of dielectric. Okay. Now comes your another thing, that that is D is equal to epsilon naught E plus P. Okay. Now what is P actually? What is P? Now P will be directly proportional to E vector. The more will be the applied electric field, more will be the polarization. So there is the proportionality constant is written as, P is written as epsilon naught into xi E into E, where xi E is called as the electric susceptibility. This is called as the electric susceptibility. Okay. Now P is called as the electric susceptibility. Now from here what you will write? You can write it epsilon naught E plus P is epsilon naught into xi E into E, and D is what? D you can write it as epsilon into D is the electric displacement in a medium. You can write it as epsilon into E vector. So from here you can write epsilon is equal to epsilon naught into 1 plus xi. Okay. Epsilon is equal to epsilon naught into 1 plus xi. So this is also a very important relation. This is the epsilon is what the dielectric constant, and epsilon naught is the permittivity of free space, and xi is the electric susceptibility. Okay. Now another thing is that the dipole moment is denoted. How the dipole moment is denoted? Dipole moment is denoted as mu. So mu will be proportional to E. Okay, again mu dipole moment will also be proportional to E, because more will be the electric field, more will be the dipole moment. So there a proportionality constant is given that looks like the proportionality sign only, that is written as alpha, where alpha is the proportionality constant and alpha is called as the polarizability. Alpha is called as the polarizability. Okay, alpha is called as the polarizability, and from here you can alpha is equal to mu by E. Okay, so from here you can calculate its unit from here only. Okay, Now alpha is written as how? Alpha E electronic polarizability plus alpha I plus alpha O, where alpha E is called as the electronic alpha E is called as the electronic polarizability, alpha I is called as the ionic polarizability, and alpha O is called as the atomic polarizability. Okay. Now from here you can write that P is what? P is equal to N into mu. Okay. Now mu is what? Mu is equal alpha E. Alpha E means alpha E plus alpha I plus alpha O into E. Okay. So from here you can write that P is equal to N into alpha E plus alpha I plus alpha O into E. Okay. Then our next topic comes as your Clausius-Mozarty equation. Clausius-Mozarty equation. What is this Clausius-Mozarty equation? You don't need to know the details of this, you just need to know the equation. Okay. So for a cubic system, symmetry crystal, okay, k minus 1 by k plus 1 is equal to n into alpha by 3 epsilon naught. This is the Clausius-Mozarty equation. You can have certain problems also from this, where everybody knows k is what? K is the dielectric constant, n is the number of atoms per unit volume, alpha is the polarizability, and epsilon naught definitely is the permittivity of free space. Okay, so these are the topics which we will have for dielectric. I hope you can answer all the questions which I will give for your assignment.